Hello everyone, this is Vijay Lakshmi Subnari from WinMaths YouTube channel. Here WinMaths is a free YouTube channel helping students across Karnataka to excel in their PUC board exams and various competitive exams. This channel helps to those who are studying PUC and guide you in making a preparation for PUC examination and also for various competitive exams. Okay, now in last classes we already discussed about the concept sets, equal sets, finite sets, infinite sets, empty sets, and some of the concepts regarding that concept as well as some based on the concept we have discussed the examples and also solved the exercise problems. Here in this session we have to discuss the next concept that is called the subset. Okay, here there is a next concept subset. First, let us consider here I consider one set X. Okay, here in that X set, I have considered set of all the students, set of all the students in the all the students in the school, all the students in the school. Okay, now based on the all the students of the school, I will separate the students from class wise. Okay, here I have considered another set Y, that is set of only 10th class 10 student or 10th class students. Okay, 10th class student, or else I will take class 10 students. Okay, here X is the main set. Okay, X is the main set. From this set, I have considered the some student based on the one familiar character. From that character, I will make another one set. So this one is called the subset. Okay, from the main set, I will make another one set that is called the subset. This is the main set and subset. Okay, now we will discuss the definition right now. A set A is said to be a subset of B if every element of A is also an element of B. If in case I have considered two sets A and B, if A is said to be a subset of B, here A is said to be subset of B, then it contains some of the elements from the set B or else every element of A from and also element of B. From taking B set, I will write all the elements or else I will collect only some of the elements. Based on the set B, I prepare one set A. That set A is called the subset of B. In this section, B means the main set and A is called as a subset. Okay, while discuss the concept, we will clarify our doubts. Okay, now I consider now, now I consider here in other words. Okay, usually this symbol Usually, this symbol shows the subset. Okay, this symbol shows the subset. This means B is the main set and A is the subset of B. The representation of the symbol represents the subset where A is an element belongs to A. If I will take one element A from the set A, it is belongs to B set also because B is the main set, A is the subset. Okay. Whenever we say about A is a subset means every element of A is present in set B. Okay. This is called the definition of the subset. Then it is often convenient to use the symbol implies. Sometimes we have to use the symbol implies. Implies means an element which is belongs to in A set as well as the same element is belongs to set B also. That time we have to use the symbol implies. This symbol called it as a implies. This symbol is called it as a subset symbol. Okay. Using this symbol, we can write the definition of subset as follow here. If A is subset of B means, for example, or whatever the element A we have taken, that element belongs to A means must and should, that is element is belongs to B also. Okay. Whenever the elements of set A belongs, that element should be belongs to B also, because B is the main set. From this main set, I will prepare another one set A that is called as a subset. Okay, I will say another one time for the definition. Set A is said to be a subset of set B if every element of A is also an element of B. Okay, now discuss the example or else another one definition. A is subset of B means A is subset of B means if A is an element of A implies A is also another element of B. Okay, the symbol have taken in a written. Okay, if A is a subset of B means if an element A is belongs to A and also the element A belongs to B only. Okay, now take here. It follows from the above definition. We say every set A is a subset of itself based on the definition. For example, I will consider the two set. One set A containing the elements 1, 2, 3 and B is a set containing the elements 1, 2, 3. Okay. Here, if okay, from the above definition, we say in these our main set and A is the subset of B means sometimes every set is itself a subset. Here B is also containing 1, 2, 3, and from that main set I have prepared another one set A that is also containing 1, 2, 3. Both are same elements. Okay, and both the sets are called it as a equal sets. Now, based on that concept, we define that every subset is again itself a subset. That is, every set A is itself a subset. That is, I can write it as A is subset A because whatever the elements containing A, it is also present in that set because both are the same set. Since the empty set has no element, already we know about the empty set, a set which does not containing any element, that is called as a empty set. Here, empty set is the subset of every set. Okay, empty set is the subset of the every set. For example, I will consider one set A, 1, 2. Okay, and set B containing the elements 1 only. Here A is the main set and B is the subset. That time I can write it as B is the subset of A. It means always we have written in front of this symbol. For example, or else in right side must and should be it is the larger set or else larger set or else it both sets having the same elements. Okay, A is always larger set or else A is equal to B. That time B is called as a subset. Okay, now I will consider C as a one set. That time C is also subset of A. C is also subset of A. It means every every set containing a empty set as a subset. Okay. Now let us move on the example. We will discuss example one by one. That time the definition will be clarified. The set Q of rational numbers is the subset of the real numbers. Okay. Here, a real number means here real number means it containing all the numbers. It containing all the numbers. So, based on the real number, I can write as a rational numbers. Okay. It including rational number, irrational, whole numbers, natural number, and so many numbers it containing real number. So in that real number, I will take only rational number. Means here the set of rational number is the subset and the set of real number is the main set. So we have to write this in the form of Q is the subset of R. Okay. Now, next one example. If A is the set of all divisor of 56 and B is the set of all prime divisor of 56. Okay. Here, first we have to write the sets. I will take A, the set of all the divisor of 36. Divisor of 36 will be 2, 3, means 3 and so on. Again, the set B containing the elements prime divisor of 56. Prime divisor, we already know that 2, 3, 5 is not the divisor of the 56. Then 7, not. Okay, only 2, 3 divisors. Here also 2, 3. And somehow are there, but I will consider only 2, 3 here. Then B is the subset of A. Yes, definitely B is the subset of A because here in the set of all divisor means it containing it containing some of the divisors 2, 3, 4, then 56. Yes, so we have to calculate divisor of 56. I will take here 2. 2 to the 4, 2 8 the 2 ones are 2 fours are 7 twos are and 2. The divisor of 56 is the 2, 3, 7, 14, 28. These are the divisor of the 56. Then we have to consider the set of all prime divisor. Here 2, 3, 7 are the only prime divisor. Here A is the main set and B is the subset. From that main set, the main set containing more than 3 numbers. So it is the main set and B is the subset. That's why B is the subset of A. We can write it as B is the subset of A. Now let us consider the third example. Okay. That is, let the set A containing 1, 3, 5 and the set B containing x such that x is a odd natural number less than 6. So first I can take set form 1, 3, 5 and the set B containing the elements odd natural number less than 6. That is 1, 3, 5. Okay. A containing 1, 3, 5, B containing 1, 3, 5. Now, A is the subset of B or else I can say B is subset of A because A and B both containing the same sets Therefore, A is subset of B or else B is subset of A. Okay. Then based on this concept, we have to take it as equal sets. Therefore, A is equal to B because A is containing 135 and B containing 135. Okay. Now, let us move on the fourth example. Let A be a set containing the elements A, E, I, O, U and B be a set containing A, B, C, D. Then A is not a subset of B because A is not a subset of B. One reason here B is the main set. Okay. B is the main set. Okay. So from the main set we have to collect the elements. Okay. From the main set we have to prepare the set. Here A containing A, E, R, O, U. Okay. A, E, I, O, U. Main set is different and the subset, the elements in main set and subset both are different. In main set, C is there. Okay. B, D is there. But in the subset, the elements are not there. And also, the set A containing A, E, I, U. E, I, O, U are not present in main set. Not present in main set. That's why it is not a subset. Okay. A is not a subset of B or else B is not the subset of A. Okay. I can say in both ways also. A is not. So that's why it can be written this like this. A is not subset of B or else B is not subset of A. Both cases are true. Here, in that type, okay, in these cases, there is another one important definition is superset or proper set. Another one important definition is proper subset or else superset. If A and B are two sets, okay, here A and B are the two sets. If A is subset of B and A is not equal to B, then A is called the proper set. For example, I will consider the set A. Okay, here B is the main set. Okay, B is the main set containing the elements A, B, C, and D. Okay, B is the main set containing the elements A, B, C, D, and A is the subset of B, that is A, B, C. That time A is not equal to B because A containing A, B, C and B containing the A, B, C, D. Here there are four elements and here three elements. A and B are not equal to, not equal means both containing different number of elements. That time it is called as a proper subset of B. Okay, proper subset of B. It means from the main set, the main set and subsets are both are having the same element. That time both having the same elements. That time it is called equal sets. Okay. Here main set is greater than the subset. Main set is greater than the subset. That time called it as a proper set. Okay. Main set must and should main set containing more than one element or at least one element other than the A. Okay. The main set containing element other than the A called it as a proper set. Okay. Proper subset of B. And that time B is called the superset. main set, or the main set called it as a superset. If A and B is the main set, from the main set I will prepare one set A. A is containing less than one element from the set B. That time it is called as the A set is called as the proper set. Then this one B set is called as a superset. Okay, it is clear. Now let us move on the next one concept. If A has only one element, we can call it as a single set. For example, the set containing only one element, that time it is called it as a single set. Okay, singleton set. The set containing only one element, that time it is called it as a singleton set. Okay, now here the element A is the singleton set. We discuss the one by one example. Here, example number 9. Consider the sets. Okay, consider the set. Here, the set is the empty set. The first one element represents the empty set, and the second one set A containing the elements 1, 3, and the set B containing the elements 1, 5, 9. The set C containing the elements 1, 3, 5, 7, 9. Insert the symbol. Here the symbol represents the subset. This symbol represents the not subset between each of the following pairs of the sets. Okay. Here, first one question. Null set is belongs to B. Okay. Null set is belongs to B because every set containing null set as a subset. Means null set as a subset. Every set containing null set as a subset, or else empty set is the subset of all the sets. Okay. Now here A containing the elements 1, 3 and B containing the elements 1, 5, 9. Both sets are differ. Okay. Here A not equal to B. Both the elements are differ. That's why A is not a subset of B because they can go on. Okay. They given only subset or not. Okay. We have to check subset or not. So here A is not a subset of B because here there is a 3 element not present in set B. Next, A is the subset of C. Yes, of course, because here C is the main set. Here C is the main set. From this main set, they can take only 2 elements, that is 1, 3. Okay. Therefore, A is the subset of C. Now again, B is the subset of C or else. Okay. Here, the C is also main set here. Then the set B containing 1, 5, 9. Yes, 1, 5, 9. Okay. Here B is the subset and C is the main set. Therefore, B is subset of C. When you try to solve more example, then the concept becomes very easy for you. Okay. Now, let us move on the next one example. Example number 10. Here, let the set containing the elements A is A, E, I, O, U, and the set containing the elements B, A, B, C, D. Okay. Here, A and B sets are different. That's why I will rate it as a A is not equal to B. Okay. A is not equal to B. Now, is a subset of P? No, because the set A containing the different element and also B containing the different elements. Therefore, A is not the subset of B. Okay. So, I can write the solution here. That is, A is not subset of B. A is not subset of B because A is containing other than B. Next, is B a subset of A? No. B is also not subset of A because B is also not contain B is containing A, B, C, D, but A does not containing the A elements A, B, C, D in that means. Okay. Now let us consider the example number 11. Let A, B, and C be the three sets. Okay. Here A is one set, B is one set, and C is the one set. If A is belongs to B, means A is belongs to means here A is a one set, the set which is belongs to B. So first I can write one set B. Okay, the elements 1, 2, 3. Okay, here the set A. Okay, here the set containing the elements 4. Okay, here A be a set containing the element 4. Here I can take B is equal to 1, 2, 3, 4. Based on the definition, I can take the sets here. And B is the subset of C. B is the subset of C means C is the main set and B is the smaller than C or else equal to C. I will take the elements 1, 2, 3, 4, 5. Okay, this is the example. Now, check the result here. Is it true that A is subset of C? No. It is true about the A is subset of C? No. Because while considering the set, in that set, it always represents the element. Okay. It is always represents the element. First, we will consider as a set the set C containing the elements 1, 3, 1, 2, 3. Here I can write another one bracket with an element. Usually in between the outer bracket, I can write the smaller bracket. Usually it represents as a element. Okay, it is represent as a element. So an element 4. Okay, an element 4 belongs to C. So A is belongs to C means, but A is not an element A is belongs to C, but A is not a subset of C. Okay, take this one example. Okay, this is the perfect example for solving the example number 11. Okay, now let us move on the next concept. Subset of set of real numbers. Okay, while considering the real numbers. Okay, while considering the real number, based on the real number is the main set. Okay, here a real number is the main set. From the real number, we have to make as a two part. One is the irrational number and another one is rational number. Then Based on the rational number, again I will make it as a two groups. From the irrational number, we have to take the two groups, that is integers. Okay, here rational means integers, integers, that is positive integers and negative integers. Here the positive integers containing whole numbers as well as whole number. Again whole number is containing natural. Okay, this is the number system. Okay, this is the number system. So here R is the main set. While considering real number as a main set, from that set I will take as a subset of all these. Okay, if a rational number is the main set, that time positive integers and negative integers are the subset. If I consider positive integer as a main set, that time whole number and whole number is the subset. Again I will take whole number as the main set, natural number is the subset, because whole number containing the elements 0, 1, 2, 3 up to 7. But natural number starts from only 1, 2, 3 up to 7. Okay. Therefore, based on this number system, I can write the relation among the subsets are the natural number is the smallest set. Okay. Natural number is the smallest set. Natural number is the subset of the integers. Then again, integers are the subset of the rational number. Integers are the subset of rational number. Then I will take a rational number. Again, rational number is the subset of the real number. Okay. Here, T is the subset of real number, means T be any set containing the elements. It is also subset of the real number. Okay. Then natural number is not a subset of T. Usually here T is the composed of all the real number. T is the composed of the all real number, means here all real number means it containing some points also. It containing T means terminating real number. T means terminating real number. Terminating real number means from the terminating real numbers, there is no natural numbers are there. Okay. Based on that, natural number is not the subset of terminating real numbers. Okay. So, based on this, we will move on the next concept, that is intervals. Okay. I will discuss the concept intervals. Intervals as a subset of the real number. Intervals are the subset of real number. Usually the word intervals. Okay. Usually the word intervals means there is a end point. There is a end point. Okay. Interval means there is a end point as a subset of the real. There are, for example, there are 2 points are there. These are the end points. So we will take in between the value, or that value R says as the subset. For example, in a number line system, we have to study from this point to this point. In between these numbers, that time we have to use the intervals. Okay. Here there are two intervals are there, open interval and closed intervals. Okay. We will discuss one by one here. Let A and B belongs to R. Okay. A is always less than B. Here there are two endpoints are there. One is A and another one B. A is always smaller than the B. Okay, A is the smaller number and B is the larger number. Okay, now Y here, the set Y such that A is less than Y less than B. Okay, here Y be an any number. Okay, Y be any number in between the point AB. Y be a any number in between the points A and B. Called it as a open interval. Okay, so we will consider any number between the intervals A comma B. That intervals are called it as a open interval. Usually open intervals are denoted by the A comma B. Open intervals are denoted by the bracket A comma B, round bracket, that is A comma B. Then all the points between A and B belongs to the open interval A comma B, but A and B themselves do not belong to these intervals. Usually in open interval, in between the elements of AB present, in between the points AB, we have to consider the space in between AB, that is called as a open interval. A and B, the points A and B are not belongs to this interval. Okay, that is called open interval. The interval which contains the end point. The interval which contains the end point also called it as a closed interval. For example, I will take this one end points in that both the place, then these 2 points are also included. That time we have to call it as a closed interval. The endpoints are included, that is closed. The endpoints are not included, that is called the open interval. Usually the closed intervals is denoted by the bracket closed. Okay, that is square square bracket under the square bracket. Thus, the square bracket A comma B is equal to X such that A is the endpoints are included. We have to consider this less than or is equal to. Usually, the symbol less than or is equal to greater than or is equal to represents the close intervals, and only less than and greater condition shows the open intervals. Okay, we can also have the another two intervals are there. We can also consider the two intervals. One end is open and another one end is closed. Here first I will consider this interval. The left hand side is called as a closed and right hand side is open. These type of the intervals are called as a semi-open or a semi-closed interval. First have to consider the closed intervals. That's why we call it as a semi-closed intervals. When where the closed interval is there, that side we have to mention the less than or is equal to condition. Then for the right side, there is a only open interval. So in this type, I have written only less condition. Okay. Now here the second one is the first open interval is there. So I will call it as a semi-open interval. Semi-open interval. Usually here the open interval denotes only less condition. Then B is the less than or is equals to. We have to say that these are the strictly conditions. These symbols are called as a strictly condition less than or greater. Means strictly the endpoints are not included. Okay. Now let us move on the concept on real number. Various types of intervals described above as the subset of the real number as shown in the figure. Okay. Here The closed interval means usually the black. Okay. Here the black endpoints denotes the closed interval means the endpoints are included. Here in the open intervals, the endpoints are not included. Half closed intervals or semi-closed interval means here the black point represents the closed intervals and the white point represents the open interval. Here this is the hemi-closed or else this one is the semi open interval. Okay. Now move on the next concept. Here we note that an interval contains infinitely many points. Interval means in that range so many points are there. Okay. We exactly don't know about the point. For example, we will discuss the example here. The set x such that x is belongs to real number minus 5 is less than x less than or is equals to 7 written in a set builder form can be written into the interval form. Okay, here they given in a set builder form, we can write it in an interval. So first we have to write the numbers, that is endpoint 5 and 7. There is a comma, we have to write the first endpoints. Here there is a minus 5 after less condition is there, less than symbol is there. So have to write the open interval. Here less than or is equal to condition is there. So I will take it as a closed interval. Okay. This is again sometimes they given in an interval form. Okay. Here they given in an interval form. We can write it as here in a set builder form x such that minus 3 and 5 are written. Here there is a close interval is there, so I will take less than or is equal to, there is an element x. Here there is a open interval is there, so I will make a less than condition. Okay. Now move on the last concept, that is universal set. Universal means the basic set for all the set is called as the universal. Universal means there is a main set. Universal set means there is a main set. But while using the main set, we have to write the so many sets. For example, A, set B, and set C. So many sets are, we can write it as a subsets. So universal set means here it is a basic set containing all the elements. Usually universal set is represented by the letter U and all its subsets are letters are the A, B, C, etc. Okay. Up to this much I will cover the concept, subsets, proper set, supersets and intervals. Universal set. Okay. All the concepts have to recall once and read it once. When you read the concept more and more, you will clarify it. Okay. If you really like my channel, please do share, subscribe and like. If you have any doubt regarding this class, please write your doubt on a comment box. Please share and send to your friends.